Okay, 7.6 function operations. So function operations are going to be like addition, subtraction, multiplication, and division, only we're doing it over a function now, not just some numbers. So starting off, we need to say, what are the function operations? So we say, well, we have addition, f plus g of x is equal to f of x plus g of x. For multiplication, we have f times g of x, and that's equal to f of x times g of x. We have subtraction, so f minus g of x is equal to f of x minus g of x. And lastly, we have division, so we're going to say f over g of x is equal to f of x over g of x. Now this might look very intimidating. It really isn't that bad. Remember, we have our functions listed here, and that's telling us what operations we're going to do. All of them are listed there in the same way. And then this x here on the end tells us what our variable is. Just like how f of x, whenever it's written f of x, that's saying we have function letter f, and x is our variable. All right, don't make it more difficult than it needs to be. So, first example, we're going to find f plus g and f minus g. Then we're also going to find or list the domain. All right, remember, domain is the x values. So we're going to list what x values could go into these functions. So we have, I'll label this number 1. We have f of x, which is equal to 3x plus 8. Then we have g of x, which is going to be 2x minus 12. All right, starting off, I'm going to say, well, f plus g of x is going to be equal to f of x and g of x. And you just plug them in. So I'm going to have f of x is 3x plus 8. So I'm going to say 3x plus 8. And then g of x is 2x minus 12. That's all. Don't make it more difficult than it needs to be. This is equal to 5x minus 4. And we're supposed to list the domain. And really what we're looking for, is there anything we cannot plug into x here, right? We have 5x minus 4. The domain, oops, I'll just put a little d with a semicolon there. Domain is all reals. I normally do that little symbol. Think of the paragraph symbol, but turn it into an R. You could also write out all real numbers. You could write that out as well. All right, next up we have the subtraction version of it. So f minus g of x. I'll put a little squiggly line there so they're divided. Well, f minus g, we're going to do the same thing, except now we have to put some parentheses and a subtraction sign in there. So we're going to say we have 3x plus 8, and then we're plugging in g, but we really have to subtract it. So I'll have minus parenthesis, and then I'll put in g. So 2x minus 12. I'll distribute my negatives. So it's going to be 3x plus 8 minus 2x plus 12. That's going to be, what is that? X plus 20. There we are. And again, our domain is going to be all reals. Unless you have a fraction or a root, you're going to have all reals. Right? Think about a fraction can't have 0. That's what we're going to look for. And a root can't have a negative under it. An even root can't have a negative under it. All right, so that's number one. Next up, we're going to deal with the multiplication and the dividing. So we're going to say find f times g and f over g. Then list domain. All right, so number 2. This time, f of x is going to be x squared minus 1. G of x is going to be x plus 1. So starting off with f times g. So we're going to say, well, we have f times g of x. So I'm going to put parentheses, and I'm going to put f and g inside them. So I have x squared minus 1 and x plus 1. Whenever I multiply out, I'm going to have x cubed plus x squared minus x minus 1. And there's actually no simplifying that I need to do there. That's it. So I'll just rewrite my work here. This is my answer. And my domain is going to be all reals, right? There's no root and there's no fraction. Next up, I have f over g of x. So this one here, I'm going to have to write them in a fraction. My f goes on top, so it's going to be x squared minus 1. My g goes in bottom, x plus 1. Now, notice that the x squared plus, the numerator there, the x squared minus 1, that's a difference of 2 squares. So there's a fancy way we can factor that. We can split it up into x plus 1 and x minus 1. Now we can cancel out the x plus 1's, and we're left with f over g of x is equal to x minus 1. And that's it. That's our answer. Now we have to list our domain. And this is the first one where it's actually kind of tricky here. We didn't have a fraction in the end, but we had a fraction in the beginning. We have to worry about that fraction in the beginning. This piece here cannot be 0. So x plus 1, I want to see what would make it 0. If I plugged in a negative 1, it would make it 0. So the domain is going to be all reals except x equals negative 1. Right? We can do everything but negative 1. Negative 1 would make that denominator equal to 0. All right. So those are the function operations: addition, subtraction, multiplication, and division. Next up, we want to look at composition. So we have composition, or function composition. Right. For this one, we're going to think about, we plug in a variable sometimes, right? We plug in, like, say, x equals 5. We plug that into a function. What if we plug a function into a function? Sometimes this will be written as GOF, where it means g composed of f of x. The easier way to read this is equal to the same thing as g of f of x. Right? Think about, you have function g. Inside function g is function f, which uses function x, or which uses variable x. All right, let's do an example of this. Example number 3. We'll say f of x is x minus 2. G of x is x squared. We're supposed to find g composed of f of x, or gof. And then after that, we're supposed to then evaluate GOF of, we'll say -5. All right, so first we're going to find the general composition function there. Then we're going to plug in a -5 to it. So we have G, let me change colors here. G composed of f of x. I think that's really difficult for me to think about. This is always the same thing as G of f of x. So what we're going to deal with is we're going to put this f of x inside G, right? F of x is x minus 2, and we're going to put it inside the x squared, So G of f of x is going to be equal to, there's my x squared, right? I just opened the parentheses farther, and I put f inside it, x minus 2. Right, and that's the composition piece of it. To make this prettier, to make it easier to read, I'm going to distribute this. This will be x squared minus 4x plus 4. This is my composition. So that's the composition that they wanted. Now we're supposed to evaluate -5. So I'm going to say, well, GOF. It's not really an O. It's like a little dot circle. Of what are we supposed to do? -5. That's going to be -5 squared minus 4 times -5 plus 4. So 25 plus 20 plus 4. That's going to be 20, 30, 40, 45, so 49. So there we are. Again, don't make this harder than it needs to be, right? Just work it straightforwardly. Anytime it says any kind of GOF, or sometimes it'll also say FOG, F-O-G of x. This is f of g of x. All right. The first letter that's listed is the one that goes on the farthest outside, right? This one is the farthest outside, just like how the g was. And then the one that's closer to the x goes on the inside. So that's that. Let me know if you have issues with your homework.